If you want to grow as a JavaScript developer, if you want to work in a big company, in a big project, please learn TypeScript. Yes, please learn TypeScript. I'm saying this please for the first time for any language because this is going to change your life. You need to watch this video till the end to know why I'm saying this please for TypeScript. So first thing first, what exactly TypeScript is? So TypeScript basically an enhanced version of JavaScript, and we can call it the superset of JavaScript. So why we need the TypeScript if we already have the JavaScript? Because of some limitations in TypeScript, there is a strong need for the TypeScript. TypeScript name suggests TypeScript. That means TypeScript provide the static types in JavaScript. What that static type means? So suppose you have created a variable which is going to store the numeric digits. So what should be the type of that variable? Obviously, it must be number. But in JavaScript, you can assign a string to a variable which previously holding the numeric number. That's not a good thing because this can change your code at any given time. To protect these kind of things, we need the typing system in JavaScript, which is still lacking, and that's why we have the TypeScript, which is a superset. That means every time you write a TypeScript code, you basically use JavaScript, you basically write JavaScript, but with some added benefits. So where we can actually run the TypeScript? You cannot run TypeScript at anywhere because all you need is JavaScript. Our browser understands JavaScript, not the TypeScript. So what we can do with the TypeScript? TypeScript actually provide a layer over the JavaScript, and that layer is the typing layer. When you write your code, that TypeScript is going to warn you. When you compile your code, that TypeScript will going to give error if some potential error is found because of some different mismatching in the type. Like I suggest you, if you are trying to assign a numeric digit into a string variable, that's going to be a potential error. So TypeScript is going to catch all the error before it can generate the real JavaScript for you. So at the end, yes, we need the JavaScript, but you write code in TypeScript, and as I said, TypeScript is just a superset of JavaScript. So if TypeScript is so great, can I use it for my single page JavaScript application like a side project or a portfolio website? Yes, you can, but you should not. You do not want to waste your time just for the typing system. So where exactly the TypeScript is useful? As I said, it's useful in a big project, in a collaborative project where you have a lot of team and all want to write on the same project, and then you need to make sure you are always using the similar kind of typing system for everywhere, because no other developer knows what the variable type is if it's not typed strongly. So that's why the TypeScript is essential in a big project where you have a lot of complexity, where you have a team involved, and that's why I said in the beginning of the video that if you want to grow, if you want to work in a big company, in a big project, you need to learn TypeScript. And this is real reason I said please learn TypeScript. So what are the benefit TypeScript provide over the JavaScript? So just like the generics, the interfaces, the enums, and many more things are available in TypeScript which are lacking in JavaScript. So I'm very excited to start this video, the TypeScript course for you. It's a basic course for everyone. If you already know TypeScript, that's also going to work for you. If you don't know, that's exactly for you. After this course, we will going to learn more about the TypeScript in some other course, how we can use the TypeScript knowledge with other frameworks like Vue, React, or maybe Svelte or Angular. So let's start this TypeScript course.
To get started with TypeScript, we first start with writing a index.ts file, and ts is the extension for all the TypeScript files. Now we have this index.ts file. So what we can do, a JavaScript file or a TypeScript file are exactly same. The difference is, in TypeScript you can define the types given by the TypeScript. So as you know, TypeScript is a superset of JavaScript. That means it's absolutely JavaScript but with added features. So I'm doing a normal JavaScript. Let name is equal to Sarthak. Okay, so that's it. And this error is coming because of the TypeScript. So if I change this to JS, see, there is no error. And by the way, I'm using this VS Code. Also, I have a very nice extension called error lens, which actually check the file and for any error. So this is checking and giving this error. Cool. Once again, let's get back with the TS file. So what we are going to do, we are just saying console.log name. It's normal stuff. Now, it's very important to have a node installed in your system. If you don't have, you just need to open your browser, search for Node.js, and then you can install the latest version, stable version. That's great. Once you install it, you will get this kind of version when you do node-v. Now let's run this file. So node index.ts, not JS, and it's working absolutely fine, just like a JavaScript file. So what if I change it to JavaScript file? So I have JS and I have same. Okay, so that should be JS, not TS. So what is the use of the TypeScript? Why we need the TypeScript if absolutely same output is here? So the TypeScript is actually made for developers, for the person who is writing code in JavaScript. Because in JavaScript, the types are all messed up. So why I am saying this? Because you can see it's very easy. Console log name is a string, the name value is Sarthak. But what I can do, I can assign a number, and that's absolutely fine because JavaScript doesn't care about anything. And if I run it, we are getting 1 as a number, and we can check. Okay, so let's see the type for this name. It's a number. If I comment this and then I run, it's a string. So isn't it like confusing? What is the real type of this name variable? Since we are on the VS Code, and VS Code is really great, and you can see once I hover over the name, which is a variable, its type is a string. And this is absolutely amazing because now we are getting this string. What if I change it to number? Now let's see. The name is becoming Annie. What is Annie? Okay, it's complicated. But for now, you can see if I say here, it's a string, and then suddenly the type is changed to Annie. Once again, if I run, the number is here. Type is a changing thing. So if I do the name as false, and then I do the type of name, and you will see two console, one is number, one is boolean, and we can turn around this name variable into any kind of type, which is actually creating the issue. Next question comes, why this is a problem? So suppose a very classic question is not a question, explanation. If I have two variable a and b like this, and if I return a plus b, now what's going to happen if I call this sum as 2 and 1 and 3? So let's first run it and then we will see. So first I need to actually log this thing so that we can see the real value. Okay, So one more thing, I can comment all these things. Great. Now let's run it. We are getting 4. That's easy. It's a number. But if I hover over this, it's having the value as the type as any. What any means. And similarly, if I hover over the function, it says function accepting A, it could be any, B could be any, and it can return any. So any literally means anything. And why this is happening and why we need the TypeScript? Because see, this actually summing up the two variable. So what if I say 1 plus 3? 1 as a string, 3 as a number. It becomes 13, but I want 4 because I have this 1, not a string. Why you are concatenating? I need the sum. That is because here it's any. Things get really worse when we have something different which is really bad. So what is one false? It's totally messed up thing, and that's why we need the TypeScript. But then you will say, Sarthak, we already have some types in the JavaScript. We don't need the TypeScript. So I'm just going to comment this thing and see, we have the number, boolean, and we know the string also. So what we can do actually, we can go here in this function and we can just say, hey, this A is having a type of string. This B is having a type of actually number. It should be number. So one more time, number, and it all return number. So if I do this and if I try to run it, you can see we are getting error. One is unexpected token. This is totally strange because you cannot annotate, you cannot give the type in a JavaScript file. Although if you hover over it, it's now giving that A is a number, B is a number, and it returns a number, but you cannot define the type. What you can do is A as 0, B as 0, and then if you try to run it without defining any annotation, now see, since it's a number, it should have the value as number, so we can define it here actually. Remove from here, and now it's a number, number and returning number. So this means if I give it, oops, one more time, giving error. So many errors, and we can solve this by turning this index.js file into a TS file. Just by doing this, what we can achieve, see this, without doing any typing system, this TypeScript file is giving error, and this error again coming from the error length extension. So what we can do actually, we can directly define it here that hey, this is a number and this is also a number, and this function totally returns a number, and that's totally valid thing. But now what happened if we try to run this TS file with node? We are still getting this colon, unexpected token. Why? We are doing absolutely fine. Our error length is not giving any error. We can provide it here like 1 or 1. But the point here is, this is not a JavaScript file. This is a TypeScript file, and Node doesn't know about TypeScript. Node just know about the JavaScript, and it's treating this index.ts file as a JavaScript file. So what we need the TypeScript compiler. Let's talk about the TypeScript compiler, how we can have it in the next episode. So if you like this episode, if you like Bitfume's tutorials, just go and subscribe to Bitfume's YouTube channel, and don't forget to like Bitfume's on Facebook, Twitter, and Instagram. It's absolutely amazing to share the content, all of you. We will meet in the next episode. Till then, goodbye. In the last episode, we were trying to run this TS file, the TypeScript file, with Node. So when we did this thing, it happened like this Node is not recognizing the colon. the way we are defining the type here is not recognized by this node, because this node is a JavaScript one. So that means if you guess it right, we need the TypeScript node. And how we can get that? It's very easy. We just need to install the TS node. And how we can install it? Obviously, NPM will going to help us. So NPM install, we can install globally, and we say, I need the TS node. So once you run it, it's going to install. And that's it. It's now installed. This means we can just say TS node and check the version. We are getting the version 10.4.0. Now, using this TS node, I will try to run this index.ts file, and let's see what's going to happen. So if I run it, something bad happened. So basically it says unable to compile TypeScript. That means this TS node is working. So what error we have? Argument of type string is not assigned to type number. And the error we already know. So let's fix this. And we are providing number on both places. Now, one more time, I clear the terminal and then I run this TS node index.ts once again. And yes, you can see we are getting 2 as the output because our function is working absolutely fine. And this is the power of TS node. And remember, let's try with the node once again. Still, node is not recognizing this colon. But you know what happened here is this TS node actually returns the output and compiling the TypeScript file. But in reality, what's going to happen, you write your code in TypeScript, but your browser doesn't understand the TypeScript. Browser only understands JavaScript. This means we need to find a way to convert this TypeScript file into the real JavaScript file. And that's the goal actually. TypeScript is made for developer to write the error-free code, to have the types in your code. But at the end, we all need the JavaScript to be able to understand by the browser. How we can do that? So let's just go on the Google and search for TypeScript. And the TypeScript, you can see the stable version is 4.5.2. And we need this TypeScript compiler in our system. So how we can do that? First, I'm going to write the TypeScript and see there is no command called TypeScript. So how we can install the TypeScript? Once again, NPM is going to help us. So we just need to say NPM install, and this time instead of TS node, I want the TypeScript. So since it's globally installed, it will be available everywhere. And yes, TypeScript is here. Does that mean we will able to write the TypeScript? No, because the shorthand, or you can say the command line for the TypeScript is not TypeScript, is TSC. And now we can check the version. And yes, it's the latest version, which is 4.5.4, although Wikipedia is saying 4.5.2. It doesn't matter, but we are on the latest version of TypeScript compiler. So TSC is very nice, and you can see when you write the TSC, just the TSC, you will get these kind of commands, and it's actually saying what is TSC, the TypeScript compiler. What is the use of this? You can use TypeScript and define your TypeScript file, and it will actually compile and create a new JavaScript file. That's the power. You can also create new TypeScript configurations or TypeScript project actually, and a lot of things you can do with this command. But since we want to convert this index.ts file into index.js, that means TypeScript to JavaScript. Let's see, TSC and compile this one, index.ts. Let's wait for this to complete. And yep, you can see right now we are having another file called index.js. This is so powerful. And the point is, it looks exactly same, just it's like removing of all these typing system, and see, there is no type here. This is the file we are just having after the compilation. And now we have this error which says duplicate function implementation. Why? Because index.ts, index.js, both are index file. So what actually we want this index.js into a dist or output directory. So what I can do, actually just run the tsc, and you will find a flag called output directory. Where is that? Yeah, this one. So output dir. So dir means directory, dir. Index.ts, and after that, instead of doing this, I just say output dir, and after that dot slash output. You can name it anything. You can call it dist. I call it output. Let's run it. So now the output index.js file will be inside this output, and here we have, and now you can see there is no error because the index files are different, are on different routes. Now let's use node and go to the output and run the index.js, this time JS, JavaScript, not the TypeScript. And you can see we have this 3 which is coming because we are having the function here. Amazing thing. So that's why TS TypeScript thing is super cool. And let's now move to the next topic to understand how we can start understanding the various concepts of TypeScript. If you like this episode, please share this with your friends. Don't forget to subscribe to Bitfume's YouTube channel and follow me or Bitfumes on Facebook, Twitter, Instagram. Let's move to the next topic. Till then, goodbye. Let's now understand the types in TypeScript. So yeah, the name is very easy, TypeScript. So all it do is define the type for different kind of data we have. Now at the end we are going to get the JavaScript, just like we saw on the previous episode, that here is the output and we have the index.js from this ts file. Okay, so what we have to define here, every kind of data we have, like if we have the string, then the type for the string data is a string, okay, with a smaller s. Similarly, if we have any integer kind of data, then that will be obviously number, or I can say numeric data. Okay, for after that, now if you have any true and false condition, that is going to be boolean, simple. After that, if you don't have anything inside the variable, then the variable value will be null, and that's how we have the type of null. And if we have the variable but the data is not defined, then we call it undefined. And what is the difference between null and undefined? We will see later. And last, we have some symbols, and the type is symbol, and symbols are the unique constant values. So these are the primitive types. So I can write it here. It's primitive types. Okay, now other than primitive types, we also have some object types. So what are object types? The object types are the type where we have not a single data, we have a collection of data, and that could be in the form of arrays, objects, classes, and many more things. So let's now see how we can define the types in TypeScript, although we have seen, but let's understand each one by one. So to define a string, let's say let my name is Sarthak, but if we want to define the name after the name of the variable, we need to say, hey, the type for this variable is a string. That's a super easy thing. Just like this, we can define the number. So I can say, hey, this is going to be the 22 like this. But since it's a number, we can say, hey, it's a number. So the type of this year is a number. Okay, just like here, let's say is enable. Now this time I'm going to do something different. You can do the same for any kind of type, but here I'm going to define the type as Boolean, but I'm not providing the value. I'm providing the value after defining this variable, and this is going to be the true. And that's totally fine, because first we have said that, hey, there is a variable whose type is Boolean, and after that we are defining the value. We are giving the value to the variable. In this case, we have said that, hey, the variable, its type and its value all in the same line, all at once. And this is true for any types. You can define it for any kind of types. And null, undefined and symbols are super easy, just like this. But the next important thing is types for array. Okay, so how we can define the array? So let's say my type is guest, and guest for Joe and Jenny and John. Now you can see the guest names all are a string, but how we can say that, hey, the guest is a array of strings? So just like we define, we say colon and then we define the string, and we can use the square brackets after the type. So this is the type, and after that we said that, hey, if we have the square brackets, that means this is going to be the array of strings. Now we need to see how we can define the types for a function. This is going to be interesting. So let's say my function is const kill bill. Okay, now it's going to be a function, and this is going to accept a name, and it's going to return the name, simple, and it's the name, let's say dot to uppercase. Something is weird. Why I'm not getting any suggestion? Dot to upper, why is that? Okay, anyways, let's see how I need to define the types for this variable, and also the return type of the function. So I can do something like this, that first I say, hey, let, I'm going to remove it, I say kill bill is going to be a type. So I need to define the type, and we always define the type with the colon. First, it's a function. Okay, and function is something like this, but then it says that, hey, type any. So it's not any, it's actually accepting the name, and name is a string, and also it's returning a string. Okay, so this statement from here to here is a function, but with all the types. And the real implementation of this kill bill as a function is here. So here we are just defining the type. Remember, after colon we have the types. Now if I do this, and if I now say to uppercase, and boom, you can see this is having a suggestion. Why? Because now the TypeScript know that, hey, the name is actually a string, and yes, in a string we can define the type. We can define this function dot to uppercase. Now there is one more way. You can just comment that, and you say const directly. You can say, hey, this is a string, and after the closing of this function you can define the return type as a string, and then also it's going to work super easy and fine. So we saw that how we can define the different types. And one more thing, what if I just say console.log of name? Now TypeScript is yelling us at. Why? Because it says that, hey, there is no return here but you said that it's going to return a string. Something is wrong here. So that's why it's saying that, hey, it's void. Void means nothing is returned, or any means any also include nothing. So that's, you can define either any or void. So let's say, if I say void, yeah, nothing is returned. And if I say any also include the nothing. Okay, but we need the string, so that's why let's come to here. Cool. So this is how we define the types for different type, but there are a lot of things for each of these types. So let's move to the next topic. And before that, if you like this episode, please go and subscribe to Bitfume's YouTube channel if you have not subscribed, and follow me on Facebook, Twitter, Instagram, and LinkedIn. We will meet on the next episode. Till then, goodbye. You know, TypeScript is so powerful that you do not need to define the type always. Why I'm saying this? Let's now see from here. One more time. My name is Sarthak. I'm not saying to you, I'm just writing it. Okay, everything is fine. We have this. And if I say the log type of my name, and then I can just go to 04 and then say ts node run the index.ts file, which I have on the fourth one, which represent the fourth video. Now it's a string. Hey, how you come up with this thing? And if I hover over the name, you can see it says string, and this is string as a type coming from the TypeScript feature called type inference. Type inference, I can write it for you. Type inference. Okay, so what is type inference? Actually, TypeScript is smart enough to see the data inside the variable and guessing what should be the type. Now, what if I say let year is equal to 2022, and then if I do the type for this one and run it, so first we will get the string and second we will get the number. Why? Because again, TypeScript is guessing the type of this variable year as the number, because we have defined the number inside it. Things will get different when we do something weird. What thing? Let's see. So first I'm defining it like this, and then I'm saying that, hey, it's year. So when I hover over here, it says year is any. Why? Because at this time TypeScript says that it's not having any value, so it could be have any value. So I say the type is any. Now here it's still any, here it's still any, but what if I run it? Let's see, it's getting number. This is really weird, because here the hover is saying that the value is, the type is year any. The type is any for the year variable. So why this type changed when we log it? Because at this time here we have the value as 2022, and one more time TypeScript says that seems like you have changed the value from nothing, from any, to a number. So I think I guessed it right, it's a number. Now things get interesting when I say that it's a string. Okay, TypeScript is not complaining about this thing, because at this time we are not having any kind of type defined, or I can say the type is any, which is implicitly, which is inferred. That means TypeScript is guessing. Now when I do this thing, we are getting a string. Why? Because when we do the log, at that time the last value inside the year variable was a string, and the TypeScript says that, hey, you have a string, so that means the type of year is a string. So one more time, this is type inference. We cannot rely on the type inference, but it's very useful when you directly define the value for any variable. Because now if I try to change the value as the number, TypeScript is complaining, because TypeScript is damn sure that, hey, the my name variable is a string. But the case on the year is different. Initially, TypeScript says that, hey, it could be Annie. So this is the difference, and this is the type inference in TypeScript. Now, how about some arrays? So I just comment all these things, and let's go and create a array. So I say let, one more time, guest is equal to Joe and Jenny. Okay, we have done with this thing, and now log for the type of guests, and we know it's going to be the array of a string. Let's see, and it's an object actually. That's going to be a different thing. Let's see, hover over it, and now here it says, hey, the guest is a string of array of string. And what is the difference between this and when we hover? When we hover, it's giving the TypeScript type. When we do this type of, it's a JavaScript function, it's not a TypeScript function, so which is giving object. So we can see it's a array of string. Now things get very interesting when we do something like this. Now what should be the type here? Obviously this is going to still say the object, because that's a JavaScript no. But if I hover over it, boom, a new thing appear here, which is a union, a combination of string and number array. So that means there is an array, and the value inside it could be string, could be number. So pipe sign define OR. Okay, true. Let's see. Wow, this time we are having this. So boolean is also added. So this is type inference, because TypeScript is guessing that, okay, this should be number, this should be string, this should be boolean. So again, this is going to be helpful, but as we know, we have to be explicitly define things. Okay, so let's move to the next topic in TypeScript. And if you like this episode, please go and subscribe to this Bitfim's YouTube channel, and follow me on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. Let's now start with something amazing. Till now, we have actually created the index.ts file on our own, but we need to have the configurations related to the TypeScript. Instead of manually creating the files, we have this TSC, the command line for TypeScript. And at the starting, you can see we have this init flag. Okay, so let's use this init flag and see what's going to happen. So TSC init. And now, one thing I want to do is, I want to do everything inside 05 directory. So first I need to move into the 05, and then I say TSC init. And something happened. So let's see what happened here. So it says created a new TSConfig.json file. And the thing it has enabled for us is the target is 2016's ES, then module is common.js, strict mode is on, and some other things. Let's now see the real file here. So in the 05 directory, we have this TSConfig.js, where we have all the TypeScript file or TypeScript compilation information. A lot of things are here. You can see it's a very big file, but we have some of the things enabled. So skip lib check is library checking. So the strict mode is on. So it will actually check for strict type checking. But the interesting one, which is here, is one module is common.js, and target is to ES 2016. So what we can do with this? Let's create a new index.ts file, and here I say first let name is equal to Sarthak, and I'm going to create a function called get name, and this is actually, I say, print name, let's say, and I'm going to accept the name, which is going to be the string. Yes, we know. And here we have string, and now I just need to say console.log of name. That's cool. So let's say print name, run it, and I say here ABCD. So I think I should remove this one because we are not using it. Now that's good. So how we can run it? We know we need to use TS node if we just want to run it. So we are inside the 05 directory, and if we run it, we should see ABCD. That's good. But now I'm going to use the TSC to actually compile this. So previously we saw that if we provide the ts index.js as a file name, it will do our magic. So if we run it, it will compile the TypeScript file and create a JavaScript file for us. But now what I want to do, I want to just run TSC. Once we run it, you will see the magic. As soon as we run this TSC command without any flag, without any option, it has done its magic. And the difference between the previous one and this one is, I just want to say, let's say with TSC, I just rename it and then run this command, and we will see the real magic. Okay, so that's done. So we have this index. See, this one doesn't have that strict part. This one, cool. Yeah. How this strict comes with TSC and not with the index.ts? So when we say TSC index.ts, it's not recognizing this TSConfig.json file. And if we run with TSC, it will actually get the configuration from here and then do the real magic. And that's how we get this use strict. But why we get the use script? Because, not a script, strict. Because here I explained to you that here somewhere, yeah. So strict mode is on. If I say false and then I run it, and then after you will see that we will not get that strict mode. Now we don't have the strict mode in our index.js, remember. Okay, so let's get back the index strict mode on. What else we can do? Remember, we never want the index.js on the same directory. We want this inside a output or disk directory, just like we did somewhere. Yeah, here. Okay, so how we can do that? So for that, we need to provide the output so like this. But since we are using this configuration file, we don't have to do anything on our command line. So just search for out dir. Here we are, and we just need to enable it. So uncomment that part and just say I want the dist to be the output directory. Now I'm going to remove this index.js and run this tsc command. And now you can see we have this dist directory, and inside that dist we have this index.js with the strict mode because it's following this ts configuration or tsconfig.json file. There are a lot of amazing you can say configuration you can set here. Some personally I like if you are working with the React, so you can enable the JSX. Okay, and yeah, one thing I want to show you is see here on the index.ts we are using a normal function. How about using a, let's say, arrow function? So const something like this, like here. That's okay, that's totally fine. And if I run it, it will going to run and compile to index.js, and here we get the same exact arrow function. But what if I change it to ES some other? So we have a lot of options, ES 19, 20, 21, 22, but let's have the older ES, the ECMAScript old one. So let's call it ES5. And let's see in the ES5, do we have the I didn't remember when this one is added, the arrow function. So yeah, here's the magic. On the index.ts, we are using the arrow function, which is obviously the latest one. But on the ES5, we didn't have that. So now the compiler knows that, okay, the target is ES5. That means we have to convert all the JavaScript we have written inside the TypeScript file to the targeted version of JavaScript, which is ES5. So it has actually converted arrow function into the normal function. And remember, this is a var, not a const, because at that time we just had var, not let and const. So this is the magic of using the tsconf.json file and using the tsc command directly to compile the file into the dist directory. So what that means, we can just use node and we say dist / index.js, and yep, ABCD is there. That's really great. And if you like this TypeScript course, just hit subscribe if you have not already subscribed, and follow me on Facebook, Twitter, Instagram, and we will meet in the next episode. Till then, goodbye. Now let's add the NPM thing in our project. So from now, I'm not going to use numbering because we need to work on same project again and again. So I'm just going to create a directory called project, and inside that I will actually do nothing actually. So what I have to do, I just have to create a directory called project, and then I will go into the project like here, and sorry, I have to restart it like this. Okay, and then I once again say tsc init. So init, okay, that's done from here. And then we will create the new file index.ts, once again index.ts, and make sure we have the output directory output dir as dist. Okay, now remember when we had here, so I'm just going to copy paste and okay, so paste it here. So here, remember, we can run or compile this just by saying tsc, and it will compile data here on this index.js. But what if I want to do something here continuously and I don't want to run tsc again and again and wait for the output result? This means we can run the tsc watch command. Okay, now by doing this, what it will do, it will actually watch your index.ts, and then whenever you make changes, so changed, and as soon as I click on the save button, you can see it says no error found and waiting for the file changes once again. And if you go to the index.js file, you can see it is changed, which is compiled, and I say changed again, and very quickly we have the index.js here. So this is the power of using watch flag. But as I said, we are going to use the npm actually. So how we can activate the npm? So it's very good to have the npm because we are used to do with npm run things. So I just say npm init with a y flag, and what it will do, it will just create a package.json file here, which we can easily see here. And now it says the main entry point is index.js, which I think we don't have to use. But our target here is on the script section. So I'm going to remove this test part, and I just say here, let's say start. Okay, and then what should be the command? Command should be the exactly same which we have used. So tsc watch is going to have like here. Okay, so I can run it once again, npm run start, and let's see what's going to happen. And yep, you can see it has started our watch, the tsc watch command, and again and again. As soon as I click save, go to index.js, yep, we have that inside the index.js. So this is the easiest way to getting started with the npm. But what is the use of having the package.json or npm thing in our project? Because now from here we can easily add any package, any external npm package in our project, in the ts file, the TypeScript file. Finally, I also want to do one more thing. We have seen that we just have index.ts, only one file, but in the future we can have more file. So instead of making the root directory, which is project directory, bigger, I want to move the source code into a new directory called src. So src would be the directory where we have all the source code. So we can move this index.ts here directly, and this means whenever we code inside the source, but the output will be inside the dist. So if we do this and run our compiler again and check whether we are working fine or not, and see, it's working. But we have to actually define in our TSConfig, although it is working, but we can explicitly define that, hey, my root directory is not this one, is actually the source. And this is very useful because the TypeScript compiler now knows that the project starts from source index.js or index.ts actually. So this means now it's going to work absolutely fine. Once again, if I run npm start, it's going to work as it is. So this is how we get started with our structure of the project using the npm for our TypeScript files. So if you like this episode, please go and subscribe to Bitfume's YouTube channel, and don't forget to like Bitfumes on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. I felt that we still need to learn some more basics, so I will get back to the number we have, 6, but I will just copy and paste to work on the 7th episode. And here we have the same thing. Everything is there, so let's just go inside the 07 and then npm run start, and because we have already configured everything in the last episode and we know how to do all these things. So let's start. So in this, I'm going to create a function, and it doesn't matter when if we create a normal or arrow function, but the function name is calculate total price. Okay, what that means, I want to accept some price, and since every price should be added with the tax, or let's say 18% of tax, then we should add it so that we will get the total price. So price multiply by 18% of the price. So I need to say price multiply by 0.18, and this should be like here. So price plus 18% of the price will become the total price. Okay, so that's right, very nice. And since we are on TypeScript and I have the error length extension installed for our VS Code, this is coming like, hey, price implicitly has any type. What does implicitly means? By default, TypeScript is guessing that the value of the price is any. Is it going to matter? Because if we say log, and let's first say const price of toy is equal to calculate total price with a price of 100, and then I just say price of toy and console this, and you can see our watch command is also giving the same error. How we can fix this error? Whenever I don't know what type I have to do, I just say, hey, this is going to be anyone and this will going to be fine absolutely, because see, everything is working, and this means if I open the new terminal and go inside this and I say node, run this file, and we get 118 because 100 plus 18% of 100 is 118. Now what I want to do, I want to say, hey, suppose we have a 50% discount. So discounted price will be, so const discounted price is equal to price of toy divided by 2. That's it. Yeah, absolutely fine. So this time I say discounted price, and when I run it, we know our TS watch is compiling very fast, so we can easily run this and we get 59. That's great. Everything is working so nicely. But since we are on the TypeScript, let's have some typing system here. So what is the type of price of toy? Any. What is the price of this? It's a number. How come this become a number? So this become number because we have used a mathematical expression here, and because of this we will be TypeScript will be able to infer or guess the type of the discounted price, which is very nice. But next thing I want to show is, what if we define this any as number? Now things are getting interesting, because if we hover over price of toy, this is now become number. How come? Because the TypeScript is guessing the return type of this function as the number. Since we are passing number, we are doing mathematical expression. Obviously it must return the number, so the output is number. And that's why when we calculate the price, the price of toy variable will become a number, and obviously this is a number. Now let me do one amazing thing here. So suppose this is not a 100, this is a 1230. So what should be the output of this? Something like this. And if I say 3, and yeah, but I want this number to be only fixed to 1. So what I can do, I can use a JavaScript function called toFixed, and what it will do, it will round off or just give me at the 1 digit after the decimal. Now here things are breaking. So let's go to the compiler, and now compiler says that, hey, left hand side of the arithmetic operation must be a type of any, number, big integer, or enum type. See, in programming you learn from the error more than by doing. So this error is telling us that, hey, you can only perform a mathematical expression on the variable which could be having type of any, number, big integer, or enum. So obviously we have the number. What happened here? So what is the type of price? A string? How it become a string? So see, what this toFixed function will do, it actually take the number, but it returns a string. This is really amazing, because once this function is returning a string, that means TypeScript says that this is a string, so the return type of calculate total price function will become a string, and that's why the price of toy becomes a string. And now we are dividing a string, which we cannot do, and that's why we need to tell that, hey, the output should be the number. And by doing that, now you can see we are getting the error at this stage, not at this stage. Suppose this function is deep inside the node module folder, and you are trying to do this and you are confused why this is not working, why this is a string. So in this situation, returning type, the return type of any function is very helpful. So now at this place you can see toFixed is not going to work. So how we can solve it? Remember what it says when we didn't have that. At this point it says that it could be any, number, big int, or enum. So we can add the return type as any. This is going to solve all our problem. But remember one thing, this any is very dangerous, because what if I say ABC And what if I have any here also and say ABC, everything is fine, compiler doesn't have any issue, but on index.js here is not having an issue, but when we run this file we are getting error. So this is not good. That means we always have to use the number or exact type, and that's why we have the TypeScript, and we can easily convert it by having a plus sign at the starting, and then we can provide any number which should return the real power. And finally, before closing this video, I just want to explain you one more powerful thing here, which is declaration. What's that? It was declaration. Yeah, so let me search declaration. Yeah, so here we have the declaration. What it does, it actually generate a .d.ts file which hold all the types for our function. So now, since our compiler is watching everything, we change the TSConfig, we have a new file which is just going to explain the types. So declare function as this, declare const, a variable which is price of toy as a number, and this is how everything is working. So we saw that how we can use the power of TypeScript to reduce the error, and how we can export or actually create a typed class or typed file where we have all the types. If you like this episode, please share this video with your friend. If you have not subscribed, go and subscribe to Bitfume's YouTube channel, and don't forget to like Bitfumes on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. So we have learned about various things like the TypeScript compiler, the TSConfig, NPM, and various other configurations in this TSConfig. But now we are moving very fast, so let's slow down this course a little bit and learn about the real core concept of TypeScript. TypeScript, that means we are going to learn about the types. And the first type we are going to learn about is the numbers. So what I'm going to do, I'm going to just copy and paste this 7th one so that I will get all the magic of TSConfig and this npm run start, so ts watch everything, and I will go inside this, clear everything, and then I just say let year is equal to 2022 and Happy New Year, because I'm recording this video on the 1st of January 2022. So even if you are watching this episode after some time, that's also a New Year's Day. Anyways, so let's run this and see how this is going to work. So first I need to go inside 08, and then I need to say npm run start. Cool. So by having this, it's going to watch our index.ts file, and in a new one we can simply say, hey, I first need to go into 08 and run my index.js file. So we are not having anything here, so that's why it's saying like this. But we can simply say year and run it. 2022 is here. Cool. Now let's add the type as number. Okay, so I have added the number, and this means this year is very typed, so I can not assign any string. Even though if you don't have that, the TypeScript compiler guess the type as number. So if you want to do something like this, it will not give error. We have already seen that, but we can force the type by providing something like this. Now let's learn something interesting about this. You know, generally we think about number as the whole numbers or number without decimals, but this number type can also hold the floating variable, floating numbers. This means I can say year is done, I can change it, and I say let cost is equal to 20.22. okay, it's 2022, but it's now cost. Okay, so I'm going to assign it as a number, And yes, this is a valid syntax because now if we see, yes, 20.22 is a number. So this means we have learned new thing, which is it can also hold any floating point. Now, other than that, it can also hold some of other number type like binary number. Now, how we can define or how we can write any binary number in the JavaScript or inside our code? So let's say I want to have my bits. Okay, so let's talk about the 4. So 4 in binary is equal to 100. Now how I can write it? So first, let's say my byte or actually bits, okay, is going to be 0, B and 100. So starting with the 0b is representing that this number which I have represented here is a binary number. So one more time, you can see on the console we get 4. Why? Because it's a binary number. And now even if I type it or make it as a typed, then also it's going to work because, as I said, it can hold the binary number also. Next, let's talk about the octals. So I just say octals, and let's just rename from 0b to 0o, where o represent the octal, and let's see the value of 100 or 100 in octal. So my octals, if I try to console log, 64. Great. Similar to this, we have a hexadecimal. So hexadecimals, and here if we want to write a hexadecimal number, I just need to say 0x. And by the way, this x can be capital, or this o can be capital, and this b can be capital. And let's see the value of 100 in hexadecimal also. And we have to print it also. So hexadecimal, that's right, and 256. Wow, that's really great that we will be able to write every kind of numbers using this type number. Okay, and finally I want to show you a big integer. Now, for creating a big integer, we are not able to use the number, because if we try to use it, and by the way, in JavaScript, big integer is 2 to the power 53 minus 1. So I can actually calculate it, but we have the documentation from MDN Mozilla, and here we have the big int, and this is the big integer number. Okay, so let's write it down and see what's going to happen. Big int is something like this, and wow, this is really great. But you know, one thing is also there. We can also say big int just like this. So why it's not working? Because to define a big int, you need to use n at the last, and you can see here they have used n to define a big int. Now with this, now we have a complaint about this from the error length extension I already have. It says that, hey, big int literals are not available when targeting ES20 and lower. This means we need to change the compiler or target. Actually, the target is 2016. We need to convert it 2020, and once we do that, it should gone. Yeah, it's now gone, and it's going to work absolutely fine. So you saw that we can change the target, and it will actually work with our code. So this is all about the numbers in the TypeScript and how we can hold various kind of number using this number as a type. And let's move to the next amazing type in TypeScript. But if you have liked this episode, please go and subscribe to Bitfumes YouTube channel, and don't forget to like Bitfumes on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. Now let's talk more about the numbers, because numbers are really amazing. Yes, in mathematics, also in JavaScript, and in TypeScript also. So everything is set. Now let's go to the 09 and run npm run start, and one more time go to the 9 and let's start this node. Okay, we can do that. That means we can simply say here we have this. Now we talked about the numbers and different type of number holding inside this number type. And now let's talk something about the number versus number. And you will say, what's the difference between these two? One is with a small n, other is a capital N. Oh, that's amazing. No, actually the real difference I want to explain here is the number with a small n is a primitive data type. What that primitive means, once again we already talked about, but primitive is the data type which already defined in the JavaScript world. Okay, so we have seen that when we understand that, hey, this my bits is a number, we use a small n to define the type. So what about this capital N number? Capital N number is actually, you can say, a wrapper object around this number. So what is the use of this capital N number? Let's say I want to say, hey, let value is equal to 1000. Now that's okay, that's totally fine. So when we define something like this, we are defining with the primitive. It's a primitive type. Okay, now but when we say other value and we use a new keyword with a capital N, and you see, if I say capital N, we are getting the suggestion like here, and then I say 1000, this is our number object. Okay, so let's just call console log value or other value also, both one, like this, and let's run it. And you can see, first one we get the actual number as the number, but second one is not a number, it's an object with this kind of notation. So what is the use case of this number object? Now let's see the amazing thing. So when we say capital N number, and if I say dot, now you can see we have lots of methods available for this object. What that mean, if I say max value and let's run it, you can see 1.79 something into the power of 308. This is the max value a number in JavaScript can hold. Okay, similar to that, we can also see for the min value, if I write it correctly. So min value is there. Min value goes 5 to the power of minus 324. That's really great. So you can have lots of amazing you can say methods available for this one. Let's talk one more about positive infinity. So this is going to be the infinity, obviously. That, what the heck is this? And one more important one is not a number. This is really interesting because we need this not a number, because suppose instead of passing number inside this object, I can use a string. Once I do this, you will see that if I log it correctly, if I say, hey, log the other value, and then the first one is number, that's good, that's really great. But if I say ABC, let's see what's going to happen. JavaScript is smart enough to convert the string into number, but it cannot literal string the ABC into number. So now you can see number is getting as not a number, NaN. So finally, this is all about the number and the number. Okay, so if you like this episode, please give it a thumbs up and subscribe to Bitfilm's YouTube channel. And finally, go and lots of and. Follow Bitbeams on Facebook, Twitter, Instagram, LinkedIn. We will meet in the next episode. Till then, goodbye. Now let's talk about the undefined and null in TypeScript. So once again, let's create one more folder, call it 10th, and here I'm going to remove everything, and then I will go into 10th and start npm, not here, npm run start. Let's zoom a little bit. Yeah. Okay, so undefined and null, what is the difference between these two? See, when you create any variable, so let's say I'm going to create a variable called let price. Okay, and I define it, just I'm not providing any value, nothing else, I just define it. Okay, so once you define, then if you try to log the value, so at this time, what do you think, what should be the value of this variable? So think about variable as a container. So what should be the value of container when the container is just created? That means it doesn't have anything. Okay, so if I can see cd into 10th one and running the node like here, it's undefined. Why? As I said, it's not yet defined. So what is then null then? We will talk about null, but before that, what if I provide a type for this variable? At this time also, variable price is being used before the being assigned. That's a different thing, but even after that, we are getting undefined. Why is this happening? Because as I said, we have just defined the variable, we have not put any value. But as soon as we provide the value, you will see that the number is here, and if we check the type of obviously number, and what about before, see, it's undefined, not a number. So is there any way we can manually define it? Like, what if I say, hey, this is undefined? Okay, so if I now check, and this time it says undefined is not assignable to type number. That's okay, but it should going to work. See, first it's number, then it is undefined. Now let's talk about the null. So we have this undefined thing, which means not defined value, just define the variable. But we can also see how we can learn about the null. So one more time, price is there, and we know that the type is going to be the undefined. But after that, I'm going to say price is equal to null, and then I see the price type. See, first it is undefined, second it is object. Okay, so this is one more time is an JavaScript thing, but we know that this is the value of this. If we check the value, is going to be null. So null is a value, and this means if I just go here when initializing, and if I define the value as null, and you can see null means the container is there and it is ready to take the values, but it already have a value called null, which is called like nothing is there inside that. And what is undefined? Undefined means it's not yet defined anything. So there is a difference between nothing is there and the null thing, which is called empty. Okay, so it's like empty glass which is filled with air, something like that. But we are on the TypeScript. This means we need to use these two as not as the value but as the types. Okay, so what we can do, we can actually define that, hey, the price can be undefined, and this is the type. And if I say price, or maybe first I can check the price value and the type. So undefined is the type and value is also undefined. We know these things. But what happened if we try to put something inside that? So see, it says, hey, you have defined it undefined, and you said that its value is 222, which is number. No, it's not possible. So in undefined, you can only put undefined. Similar to this, we can also do the null thing. That means using null as a type. So I say price2. So price2 and price2. So what do you think? What should be the log here? What should be the type and what should be the value? Let's see. So if I run it and we get undefined and undefined both. Why? Remember, when we just defined the variable, at that time the value of any variable is undefined. Although we said that, hey, whenever this variable can only accept null, but it can accept null when we add value to it, when we define the value of this variable. Otherwise it's undefined. So what happened if I say price2 is equal to undefined, and now it says, hey, you cannot add undefined to the type of null. And this is totally strange, because just before here we saw that it's the type is undefined already. So one more time, if I check it, and you see it's although having undefined, but still the strict mode is saying that, hey, something is wrong here. So what we can do, can we assign any number? No. As I said, this is only be assigned with null. After this, you can see now we are getting the value as null and JavaScript object as a type. Okay, so this is extremely important. Now the question comes, when we actually going to use undefined and null as a type. So see, let price3 and is going to be a number. Okay, now I can simply say the value, and then I say price3 is equal to 333, and one more time adding the value, and I should comment every other thing. And let's comment every other thing. Okay, so here we say it's type 3. Okay, now let's run it one more time and we get undefined and 333. So is that mean that we can define as the undefined? You can see we are actually getting this error, which is obviously said that, hey, you are trying to assign undefined into the type of number. So I can say, hey, this could be number, or with the union sign, the pipe sign, undefined. So now you can see the error is gone. And same if we try to assign this as a null, then also we can say that, hey, it could be undefined, it could be number, or it could be null. So we will learn about this union sign later, but for now this is the use case of these three. Now let's check the final thing. So what I'm going to do, I'm going to just say, hey, what should be the console.log if I say that price3 is double equal to null and price3 is triple equal to null? What should be the result of these two? Okay, so if you don't know this triple equal to, which is strict checking, and it's just a normal checking. Okay, so let's console.log, and first is getting true, second is false. What's the matter here? Why it's giving first true and second false. So see, when we do the comparison, we are checking for the value. When we are using double sign, it's just checking the value, and when we do the triple equal to, it's checking the value with the type. See, here it says price 3, is it null? What is the actual value? We know actual value is undefined, and undefined and null are similar. Okay, obviously not same but similar. So it says that, hey, undefined is null. Yeah, okay, that's okay. But at this point it says that, hey, it's okay to have the value undefined and null, but you know, the type is different. We are saying that it could be the type. What is the type of null? Obviously null. But what is the current type of this price 3, which is undefined? We already know. So that's why it is giving error. Now what if I check for undefined on these two, undefined, and I just comment these two. Let's see what's going to happen. True and true. Why? Because initially the value of price 3 was undefined, so it says, okay, what is the value? Yeah, same, so undefined is true. Now coming to this strict checking, it says, what is the value? Undefined. That's good. What is the type? It's also undefined, and that's why we are getting true here. And the reverse is also the case. So what if I just copy and paste everything and comment all of these, and here just before I just say price 3 is going to be null. Now, so let's first start with comparison of null. At this time, what should be the value? It says that, hey, what is the value of price 3 is null. So null is equal to null. It should be true. At this point, what should be the value? Null. But what should be the type also? Since here we have added null, it says that, okay, now the type is null, so it should return true. Okay, so let's see. Yes, true and true. Now coming to this undefined things. Now here, what is the value of price 3? It's null. Null is all okay with undefined, so it should return true. Now coming here, okay, so what is the value of price 3? Null. Undefined, yeah, value is okay. But what should be the type? The type of price 3 at this point is null, but the type of undefined is obviously undefined, so it should return false. So let's now see. And true and false. This is the way we can understand the null and the undefined in TypeScript. So I hope you like this episode, and you need to follow Bitfumes on Facebook, Twitter, Instagram, LinkedIn. If you like this episode, please hit thumbs up and subscribe to Bitfumes YouTube channel. We will meet in the next episode. Till then, goodbye. And now let's talk about the never type. And to start, we just create another directory with all our data here. Go inside that directory, start npm run start. One more time, go into that, so that if we want, we need to run the node. Okay, so let's start this, and let's clean the index.ts file, and we are going to learn about the never type. Name is very unique, never type. So how we can explain, how we can learn it? First, let's create a function, and the function is sum, which returns a as number, b as number, and it return a plus b. Okay, so when I hover over this function, what it says, this function returns number. Okay, so this is very important to see that this function is actually returning number. Now what if I am not having the return type? So if I don't have any return type, then you see it says the return type is void. So number return type, void return type. By the way, void means no returning, nothing, no value is returning, I can say. But now let's see another function. I'm going to create another function, and this function I call it raise error. and this is going to get the message, and the message is going to be the string, and then I say, hey, just throw an error and call it whatever the message we pass here. Now, what should be the return type of this? Is it undefined, void, or what? Let's see. It says void, but actually this code is never reaching beyond this line. So what this means is it's not about returning any value or no value. It's never ever returning anything. So that's why the return type of this function is never. Okay, so now the return type is never, because as soon as the code go inside this, it will throw an error and execution stop for this function. This means even after this, if you have something, that code will not going to work. And this, you can see TypeScript is not complaining about this. And if I remove it, still it's not complaining, but this code is not. So this is not working code. Why? Because it will not go after that, and that's why we have this return type. Now, what could be the another example for never type? So I can create a function and I call it forever, and what I'm going to do, I'm going to say while something is true, then just log TypeScript, and this code will never going to stop, and this means this function is never going to return anything. So what should be the type, the return type of it? This number, this function actually is actually never. So I have one question. What if I say that, hey, this function is actually returning nothing, so it should be void, and TypeScript is not complaining about this thing. Now, what if I say, let's just comment this one and uncomment the first one. What if I return this a plus b, and then I say it's a void? It says that, hey, you are returning something. What about never? It's again saying, hey, you are returning something. Seems like if I have a void and I can say let c is equal to a plus b, and this is totally a valid syntax because we are not returning any kind of value from this function, so void is totally valid. Now think about this. As soon as I said it's going to return never, TypeScript is complaining. It's saying that, hey, a function returning never cannot reach an endpoint. And this is a very nice statement, because this function can reach the endpoint, which is this one, this closing bracket. And function which not return or which never return, or I can say a function which has a return type of never will never reach the end of the function. But this function is reaching because it execute this code and it will finish this function. But think about this raise error. This, once it's raise error, it's not going to complete this function. Think about this while loop. It's an infinite loop. It will never complete this function, and that's why this is never, this is never, this is not never. This is actually a void. So I think you got the difference between void and never. Void actually not return anything but finishes the function. The function which never finishes execution of, never reach the end point of the function, called having a return type of never. So this is absolutely important concept in TypeScript to understand. I hope you like this video. Please share this video with your friends, and don't forget to hit like button and subscribe to Bitfilm's YouTube channel. We will meet in the next episode. Till then, goodbye. Don't forget to like Bitfilms on Facebook, Twitter, Instagram. I forgot that line. Okay, so let's meet in the next video. Let us start with enums in TypeScript. So I have created this 12th one, so cd into 12th, and we will do that if we need the npm run. But for now, why we need the enums? That's an important question. So I can write as enum type. So suppose in an application you have used some string values. So suppose you want to compare the name with a string value. So name Sarthak and another, let's say John. Now after some time you realize that, hey, this is not with a capital S, it should be with a small s and a small j. Now anywhere you have used the Sarthak string, you have to change everywhere. Okay, that's a really big issue. How you can do that? So you can create a constant of let's say Sarthak, which having the value of Sarthak, and then you can just compare with the constant you have created, and similar for the John. But then comes an issue. You have to create lots of you can say the names or the constant, and also you have to remember everyone. Now things will be very easy, just like an array where you can pack everything in a single name or single variable. So that's how enum comes into the play. And you need to know that JavaScript doesn't support the enum. Okay, this is actually the pure TypeScript thing. So suppose I'm going to create a enum. How we can create a enum? It's very easy. You need to use the enum keyword, and after that the name of the enum you want to say. So I say weekdays. Okay, now after this I want to give the name of each weekday, and that's it. So I can say Monday, then with a comma I can say Tuesday, and similar to others. And the most important thing here, you notice that I have not used it as a string. It's just a simple word without any string. So what we can call it, actually this is the element or the value for each of these weekdays in the enum. Now let's log this and see what we are getting when we just log this weekdays. So if I go here, we need to start we already have, I don't know. So let's start this and go into 12th one and run the node thing. Okay, so you saw it's similar but little different. What happened here? JavaScript doesn't support enum. So TypeScript made some unique thing to create the system which represent enum thing. So we will see this later and we will understand this later, but for now I'm just going to log and I say weekdays, and suppose I want the Sunday, and you can see the power of enum. We are getting the autocomplete, and this is happening because we have the enum. This will not be possible with the constant, just a single constant you can create, and that's super easy. And if I run this, amazing thing going to happen. You see we are getting 6. Why? Because the Sunday is at the 6th position. So 0, 1, 2, 3, 4, 5, 6. And this is just similar to the array thing. That means if we want, we can also get, I want the first element of this enum. What should be that? Wow, it's a Monday. So if I want the 6th one, it should be, or it must be actually Sunday. Cool. So we are getting from the actual literal name, and we also can get from the index value. Now remember I explained you or in this log that this TypeScript is actually creating some magical thing behind the scene. So maybe we can see in the index.js that enum we have created is now converted to a variable called weekdays, which is having a function which is directly called self-calling function. And then we have a weekdays, It's a little complex, but just to give you the idea, weekdays is having this value, which is having Monday and some different things, and we can understand that easily by running this. So when we log all the enum, we are not getting the kind of enum thing because JavaScript doesn't support enum. We are getting something like this: is an object with some values or key and the values. So key and the values, key and the values. Similarly, key and the values. So here things to notice is that when we said that we need the weekdays dot Sunday, it will go here and find the Sunday and give us 6. When we say give me weekdays of 6th, so it will go here and give us Sunday. And that's how actually enum work, which is really powerful and the great thing in TypeScript. Now, very important thing to notice here is that if we once again run, maybe we can run this one actually. If we run it, we can see it start with 0, but sometimes you don't want that. And the best thing about enum is that you can just tell to enum that, hey enum, I actually want this to start with 1, not with 0. And you don't have to write it like 2 and 3 and etc. You just initialize it at the starting, and then enum or the TypeScript will do its magic. So when we do this now, you can see it start with 1, 2 and goes till 7, and same here, Monday is 1 and 2 and 7. This is really helpful when you explicitly want to define the starting of any enum, you can say number index thing. So this one is actually called, the type of this enum is called a numeric enum, because the numeric is the index thing. But sometimes you also want to give the value a different thing. So if I say, hey, this Monday is actually MON, but when you define something like this, enum doesn't know that what we have to do for others. In case of numeric enums, TypeScript know that, hey, if you have a 1, we just need to increment it. But in case of a string, it doesn't know. So in that case, you have to define the value for each of these enum value. So something like this. So fry, and I can say sat, and finally sun. Okay. Now you can see there is no complaint from the TypeScript, and if I run it once again, we can see we just have this time not a dual thing. We just have one single, which is saying single object, which is saying Monday, and this comparison. Okay, so what if I try to get the Monday or maybe Sunday? So we should get, you can see sun, because we have defined Sunday as sun. And what if we want to get the 6th one? This is going to be interesting. You can see it's in undefined because we don't have any numeric index for this enum. This means we need to actually say, give me the real thing for sun. Is this going to work? No, because we don't have that relationship. We have only one relationship, which is key and the value. So make sure when you create this type of enum, which is called string enum, you have only one way to access it, from the actual key. Okay. Then you will say that, hey, let's get back to the previous numeric one. So this is the first one. But what if I want to give Sunday as the 0? So I start with 1, but I want to give Sunday as 0. And if I do this, you can see it's not even complaining, but it start with 0. That's fair, that's easy to understand. But what if I have something where I want to compute and then give the value and compute with the previous value? So this is going to be interesting, because now what we are going to do, we are going to learn about the what's that, computed enum. Yep. So what will be the case? I want this weekdays, so weekdays dot Monday and -1. Okay, so I said that whatever will be the value of Monday, whether it is 0, whether it is 1, just decrement it by 1. And make sure here we are calling the same enum. So enum is calling itself, and then if we check it, you can see Sunday is 0 and Monday is 1. If I say it's 0, it should go to -1. So Sunday is included here at the last with the value of -1. This is so interesting in the enum that you have full power of computing, giving a string, giving numbers, and that's why the TypeScript is so great that you can go beyond the limits of JavaScript. That's really amazing to see. If you like this episode, please give it a thumbs up and subscribe to Bitfume's YouTube channel. Follow Bitfumes on Facebook, Twitter, and Instagram. We will meet in the next episode. Till then, goodbye. Now let's talk about the object type in TypeScript. I'm really excited for this object type because we always use this object type in real projects. So how we can get started? So I'm going to create a variable and I call it fruit, and I'm going to define the type as object. Okay, and after that I'm going to add some field to this fruit. So how I can do that? I can say, hey, this fruit name is, let's say, mango. Okay, and I love this mango. Not this, every mango actually. And what is the taste? So taste is obviously sweet, and sometimes, or but not always. And what is the color? So color is generally yellow or green, so I call it yellow one. That's great. So let's console log fruit and see the result. I always have this running for the 13th number, and I have created new project, everything. You already know things, and we get this object. And when we check the type of, okay, it's going to be object. That's great. But if we are not defining it, then see what's going to happen. This is going to automatically get that, hey, this is an object, and that's because of the TypeScript's type inference. That means guessing the type. That's really amazing. But what if I say fruit.price, I say price is equal to 100. Okay, that's done. And if I try to get all the fruits, and oops, not that, and yes, I have this price inside this object. That's not a good thing, although you can see that TypeScript is warning or actually giving error, and we can define this, and after that we need to remove this let. After that it will be sure that, hey, something is wrong. So if I try to run this, you can see we are still getting the same error, and this is because of the strict checking, and we have no property for this price in the real fruit object. So what do you think? We are having this even without defining because of the type inference. Is it okay to have this just object defining the type? We will see this when we move to the next important thing, which is, let's say I want to get the type, let's say type of one of the property, let's say fruit.name. So yes, I can see that I will be able to get this, but TypeScript is complaining and saying that, hey, you don't have the name property on the type object you have. Hey, but we already have it. What's the issue? So the issue is when we have defined this variable called fruit, like here, at that time we said that yes, it's an object, but we have not defined the properties of this object, and that's why TypeScript is complaining that you have no information about the name. I don't know what you are talking about, although we have, after that we have added it, but original you can say object doesn't have any property. Seems like we need to modify this, and we can say that, okay, this is an object, but I'm going to define the fields here directly. So I'm going to say name should be there, and you can see it says that, hey, you are defining some property, but do you mean it should be any? No, it should be a string. So I can define that, hey, I want to create a fruit variable, which is an object. Inside that object, I have a field called name, which is having a type of string. After doing that, when we try to assign anything on this fruit object, TypeScript is complaining once again that, hey, yes, you have the name, but you don't have the taste. So that's why we need to put every property inside that. So it's also going to be a string. Now, after that, it says that, hey, that's okay, but you don't have the color. So let's add the color also. And color is also going to be the string. Okay, this is very nice. Now, at this time, when we have defined everything here, now you can see TypeScript is not complaining about anything. And that's really great. So let's add some Boolean thing here. So all season. So is it all season fruit? So it's a false. It's not an all season fruit. So I can add it. You can see once I added it, it says, hey, you don't have that field. So I need to add it here, and I call it, it's a Boolean. So after that, everything is working absolutely fine. But one more time, this is not a good thing that once we are defining the fruit, then we are assigning the real value to each of the property of object. So what you can do both of the things at the same time. So I can cut it here, remove, and I say let fruit is a type of object which is having this structure and equal to having these values. So we are doing all these things at the same time, defining the variable, defining the types of each object or each object's property. At the same time, we are also assigning the object's properties value. And this is how this TypeScript object thing works, and really, really amazing. Now, you will say that, hey, that's okay, but what about if I have to create another fruit? So fruit 1 is this, and what if I want to create a fruit 2? So let's say fruit 2, and it's an orange, and it's not a sweet. Its taste is simple sweet tart actually, and color is what's the color of orange? Orange. And I don't know about the season, so let's keep it false. Okay, now things are getting interesting. Why? Because see, all these fields for fruit 2 and for fruit 1 are exactly same in terms of the type of properties. So what you can do, you don't want to repeat yourself every time you create a new fruit with all these types. So what you have to do, you have to create a new type. So we know that these string, boolean, etc. are primitive type. Okay, but now we are going to create our own type. Yes, we are going to create our own type. So type is, I can say fruit and something like this, and then I say its property is going to be like this with a type. So yes, I have used capital F. You can use small f. It's not a problem. And once you define this type, you can use this type as a normal type like string and boolean. So what you have to do, just like we are having this object here, we can remove this object and paste it like here. So we are saying that, hey, fruit 1 is a type of fruit. And what is fruit type? Fruit type is our own type, which is an object type having name, taste, color, and all season. This means we can also create, just like here, I don't need this, and I can say, hey, it's a fruit type. That's super helpful, and you can see we have reduced the number of lines for our code. At the same time, we have a general, or I can say common type or custom type, I can say, where we have defined each and everything. So this is for the object, and let's now continue for the array thing in the next episode. And if you like this episode, please give it a thumbs up and like Bitfumes on Facebook, Twitter, Instagram. Don't forget to subscribe to Bitfumes YouTube channel, and we will meet in the next episode. Till then, goodbye. Now let's talk about the arrays and tuple. What are they and why it's useful in TypeScript? So first, let's talk about the array. We're already familiar with the array and how we can create the array in TypeScript, but let's one more time go with the fruits. And I'm trying to define it as an array, but TypeScript says that, hey, I don't know what is array. So if I say array, it's complaining that you need to give this something t kind of thing. We will learn about that later, but for now I'm not able to do that. So I'm going to define fruits is going to be an array of mango, then orange, and then apple. Okay, so we have defined this very nicely, and if I hover over this one, you will see that its type is any. What that means, if I have a true here, TypeScript says that, okay, that's not an issue because it's an anything, it can hold anything. So what if later I say, hey, fruits is just mango? Or maybe initially I can say fruits is just an mango. Actually, it's going to be fruits. TypeScript says that, oh, no problem. Even after that, no problem. And maybe after that I can say, hey, TypeScript, this is a Boolean thing. Again, no problem. But we can solve this problem by defining that, hey, this fruits is an array of string. So first you need to type the type of each of the element. So what is the element? Mango. What is the element? Orange. Apple. This is the main one. And what is the type? It's a string. So after that, we need to give the array symbol. This is square brackets, and this is the type for each element. Just by doing that, you can see TypeScript is complaining that, hey, true should be not there. Okay, I removed it. Then it says that you are trying to assign a string to the variable where the type is an array of a string, and same for the Boolean. So you cannot do all these things. And this means now we are strongly typed fruits, and we will not be able to do any kind of error. And this is really great thing in the TypeScript. And by doing that, by defining it an array, we will be able to use lots of autocomplete properties or method, you call it, available for the arrays, just like length, map, pop, push. Everything is available here. But if I didn't have that, TypeScript says that, okay, it's an any. So you can see it's getting this by type inference. So it says that, okay, it should be a string something. So I can use push, and that's great. I can say grapes. It's grapes. Yeah. Okay. But later I said that, hey, it's going to be true. And now if I say fruits and I say dot, hey, I'll lose the autocomplete and all the property. That's why it's absolutely and extremely important to define the types in the TypeScript. But the real important thing here to actually understand is the tuple or tuple, whatever you call. So tuple is a concept which is not actually available in JavaScript, but TypeScript provide it. And if you are from Python world, you may know about the tuple. So why we need a tuple? So tuple is just like a array. So we can define the tuple something like person. Person can have the name, something like this. Person can have a company name, and person can have a zip code, something like that. Okay, so how we differentiate that this is a tuple and this is an array? First, let's understand why we need the tuple. So what is the problem with the array? In this array, you can see it's not a fixed length. So we can add any number of fruits here. So just like here, I have added. Second, it doesn't care about the sequence. I can move the grapes here. It's not going to complain. And that's the reason we need the tuple. Why? Because tuple, if we have three things, it's always going to be the three things, and the sequence is very important. The first one is always going to be the name, second one is always going to be the company name, third one is always going to be the zip code. So how the TypeScript is going to differentiate between all these? Before that, let's have an analogy. So here I have a tiffin box. So this tiffin box have 4 elements or 4 chambers. In each chamber you put only one type of food. If first one is having a curry, you will not going to add a juice, fruit juice on that. First one is always going to be the type as curry. Second one, if it's a fruit, you are not going to add any other thing inside that. It's a fruit one. So each element can have different type of food, but you cannot mix that. And if the first one is for the curry, it's always going to be the first one for the curry. It's not going to be changed when you transfer the tiffin from one place to another place. It's always going to be the same sequence. And the important thing to notice here is it is always going to have only 4 chambers. So this is the fixed one. Only 3, sequence matters and type matters. But the question arises, how TypeScript know that this is a tuple? Because I can do something like, let's say I have a real example for tuple is RGB color. So color is 244, 255, maybe 0. That's good. But since this is a normal array and the TypeScript inference that it's an array of number, I can do this and I can say, hey, just spread color and add 255 after that. And no issue on that, because if I log color, we can get these things. But what if you define it as a tuple? How to define tuple? Just use colon, and remember we have something like this. It's an string array, but this time we will define something like using array. Remember we defined the object like this, name and something like that. Similar to that, we need to use this square bracket, and inside that I will say it's an tuple of number, number and number. Just by doing that, you can see now TypeScript says that, hey, it's a tuple which doesn't have 4 numbers, it's only have 3 numbers. That's really great. And that's why we are getting this error. Although there is a hack, you can use push to do the thing, but that's not a problem, because if you try to access the 4th one, which is having the 3rd index, you will get error. But we can get the 2nd one, because TypeScript know that color is having only 3 elements and the 2nd index is the last one, which is 0. You can get, but although you have added by somehow, you will not able to do that. It's giving, but TypeScript is complaining. So that's the power of TypeScript. But things get really interesting when you understand this thing. So it's an array of first string, second also a string, and third is a number. This means if I try to say person and I spread person, and maybe I can do something like that. I can say the second one is going to be a string, something like that. And at that point, you can see this TypeScript is complaining that, hey, second element, which is the 3rd one in the sequence, is a number, not a string. You're trying to add string to the number field. So this is the power of tuple over the, you can say, array, and this is why the tuple is introduced inside the TypeScript. One really real example is the React hooks. So if you know about React hooks, we have seen something, let's say set state. So what does set state look like? It's like here, I can comment it. So it's here like a form and then set form, and this is use state. Okay, so what we are doing, we have a tuple where the first element is always going to the state value, second element is always going to be the function which set the value of the state, and this is the function, it returns this tuple. So I hope you like this video. Please give it a thumbs up and subscribe to Bitfilm's YouTube channel. Like Bitfilms on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. Union type and what it is, let's understand in this episode. So this is the 15th folder or directory, and let's start and getting the idea of union type. We have already seen it, but let's go into the depth of this. Suppose I create a variable called id, and then I assign id 1 to 3. That's very nice, and type inference says that the id is a number. But if we want to assign 1 to 3 as a string, it's not getting it. But if you want the flexibility, then what you can do, you can say that, hey, id is a variable without any type, and then TypeScript will get the type whenever you assign any value. But at this point, since we have allowed to user that, hey, you can add a number or a string to id, but the problem arises because it's any type, user can also add the booleans inside that. So this is not good. We want to restrict the user to only 2 type. So if I assign it as a number, then string will complain. If I assign it as a string, then number will complain. So what you can do, you can actually use the pipe sign and then define another type, something like this. And now you can see it's working. But if I add the boolean, it says that, hey, only string and numbers are allowed for this variable. And make sure it's not having any difficulty in reversing the sequence. So sequence doesn't matter. What matter is how many types you want to add. Now later, suppose you want to add boolean also. That's okay, that's totally fine. We can add the boolean and it doesn't have any issue. Now, what is the real use case of this thing? So let's understand the real use case. So first, I'm going to create a function called print id, and then I will get the id, and I'm not defining any, you can say I'm not defining any type. Then I want to console log id and see the result. So see, first it says that it is having a type of any, so let's keep it at any, and then I say print id, and I will say 1 to 3, and let's move into 15th one, npm run start, and one more time node index, and you can see 1 to 3 is printed. Now what if I have 1 to 3 as a string? Still we have this, but things get worse when we have true, and that's what we have. Now suppose we don't know about the union type, then how we can do that? So we can check if type of id is a string, then I want to console log, and I want to just do the uppercase of it. Yes, this is very nice because we get the auto completion. And if this is a type of, or I can simply use the else part, else just console log id, and that's it actually. Now by doing this, if we see this time, okay, so something is rare. Okay, so yes, we can actually add if for our number also. So it's, if it is a number, then just console log. So now you can see we are not having any log because we are passing it a boolean thing. Now if I say hello as a id, you can see id hello is now uppercased, and this thing is not good. Why? Because we need to define that it's a number or it's a string. Just by doing that, what if I do this? So we have eliminated one possibility that, okay, it cannot be anything other than number and string. But if I do this thing, it's still complaining that, hey, it could be a number, but uppercase is only for the, you can say, string. So if I just pass number and see, we are getting error. So we can eliminate only one thing, and we just have one conditional, which is like, if it is a string, then uppercase, otherwise do any other thing. So it's just a else part. Great. Okay, so let's run it, and yes, you can see 12 is there, and one more time, if hello is there, that's great. So this is called the union type, where we can combine more than one type to define the type for any variable. So I hope you like this episode. Please give it a thumbs up and subscribe to Bitfume's YouTube channel. Like Bitfumes on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. The alias and the interface in TypeScript is actually the day-to-day useful thing. Remember, in the 13th episode, we saw this thing. This is the type alias we have created. Why? Because we need to define the type, same kind of type, 2 times, or I can say more than once. So we have defined something like that. So why not, let's copy all these from here and paste it inside this. So we have a fruit type, which is an object, and here this type, which is a fruit type, we are giving here in the fruit 1 and in the fruit 2. And this means with all these things, if I try to do something like that, since we have defined in the fruit type that all season is going to be the boolean, it's now complaining. So this is called the type alias. We are giving this type as an alias, and we already know these things. Now this is good for each of these things, but now things getting really interesting with interfaces. So what is interface? Interface is just like type. So what I can do, I can just turn this type into an interface, and I don't have to define then this equal to sign. And you can see TypeScript is not complaining about anything. It's all okay. This means if I do some type mismatch, you can see TypeScript is complaining. So why we have 2 type of defining the alias kind of thing? One is type and other is interface. So the type, which is like this, is restricted just for the alias thing. Now suppose later you want to add some more property to this fruit. How you can do that? Like you want to create another type with the same name, and then you want to say that, oh, this I want, but along with that I also want to have a price which should be a number. You cannot do this thing because now you can see it says that, hey, duplicate identity. But see the real magic. If I change it to interface, and I need to remove this, absolutely fine. This means now fruit interface is extended, is now having one more property called price. And that's why when we define any fruit, it says that, hey, price property is missing, because the interface says that it required the price also. That's wow, that's really great. At any given time we can extend the interface, and this is really super, and we can add any number of values to the original one. There are more power to the interface. Now suppose with this all these information you want to create a new you can say interface which is not going to have same name but a different name, and I call it mango. And when I say mango as an interface, I want to actually have all the properties of fruit because mango is a fruit. So if you have little familiarity with the oops concept, we can actually extend this interface from the original fruit interface. By doing this, the mango interface is now inheriting all these properties plus the new property just for the mango. So if I say fruit1, which is a mango, let's change the type called mango. Just by doing that, now you can see this is the TypeScript is complaining that, hey, you need to add the price for the type mango because mango is having a new field called price, but the orange, the original one, is just a fruit, so we don't want any pricing for this. But can we do this with the types also? So let's convert this interface into type, and with the equal to sign, first thing is says that, hey, you cannot extend any type because types are fixed. So I need to create a mango. Now in the mango, since it doesn't have any name, taste, color, and now TypeScript is complaining, but I want to do this thing. So what I can do, I want to say that, hey, this mango is actually a union of fruit and this one, the price one. So I'm going to use and sign, ampersand sign, which is saying that, hey, mango is a fruit and price. Now just by doing this, we get the same, you can say, effect. And now it says that, hey, price should be there somewhere. Where is that? Price is missing. So if I provide the pricing like this, you can see TypeScript is happy. So the same thing we can achieve, but I don't like this feature, and the interface looks real, you can say descriptive and intuitive also. And with the power of actually just writing single thing like just adding the property like this, I'm really happy with the interface thing. Now question comes, when you have to use the interface, when you have to use the type, it's always up to you. You can use any one like interface or type anytime, but since interface has this kind of functionality where you can actually add any property to anytime. So suppose you are creating any package where you want to give the user or the developer to the functionality that they can extend the type you have defined in your package, then interface is a good thing. But if you really want to restrict the user to some types of type, then you have to use the type alias. So I hope this is useful, and these are concepts are useful to you. So if you like this episode, please give it a thumbs up, subscribe to the Bitfumes YouTube channel, and don't forget to like Bitfumes on Facebook, Twitter, Instagram, and LinkedIn. We will meet in the next episode. Till then, goodbye. One more time, we have the type of fruit with all these properties. Then we have a fruit one called mango and other things, and fruit 2 orange, similar. But things get really interesting when we talk about the optional properties. So suppose, just like previously, I want to add a price, and price should be number. Now this is added, and everywhere where we have used the fruit type is asking for the price field or price property. But I don't want to add the price or give the price property to every kind of fruit. I only want in mango. So if I give in the mango a price, let's say 10, then that's okay. Fruit 1, the mango, is happy, but fruit 2, orange, is not happy. So how we can make this price field price property as an optional. That means I sometime want or sometime I don't want. This means I can do one thing like, hey, price could be number or it could be undefined. So this is okay, but still you can see we are having, it's asking for the price. So I can say that, hey, price is actually undefined. I don't know about that. So now TypeScript is happy on this. But this is not actually the optional thing. We have not omitted, we have not skipped the price. We have to define it, although it could be undefined or maybe just null. That's also going to work. But if I remove it, it's asking for that. So in this case, I want to make this field as an optional and I will use the question mark. So when I say price or the property name with a question mark, then you can see it's not asking. And even if you provide it, that's totally fair. That's totally fine. So this is called the optional parameters. Now, what if I want to log, let's say log fruit1 dot price. And if I see here on node, I need to do node. Yeah, you can see 10 is here. Now, what if I do the same thing for the fruit 2 and you can see it's undefined. It's okay because we know that there is no pricing in the fruit. Now, let's create a function and I want to give a function and say get price, and I'm passing the price field here, and this is going to be a number, and then I will return the price. Okay, and let's add 10 to it. Okay, so it's very simple thing. So I can say get price, and if I have a value of 10, let's just comment this one and run it. We get 20 because 10 is maybe you can say the something tax x kind of thing. Now let's do the same thing for the fruit1. So I say fruit1 dot price. So we have passed it and we can get the result. 20 is there because the fruit1 pricing is 10. But still, TypeScript is not happy with this thing because it says that, hey, you have defined this price as optional. What if I remove this null from here? Still, it says that it could be undefined or number. So if it is a number, that's okay, but undefined is not going to work here because you are doing some mathematical operation, some numeric operation. You cannot do that. So what we can do to actually say to TypeScript that, hey, TypeScript, it's always going to have the value. So first we can say that, hey, I want this to be like this. It's not working. So what we can do here when we are defining this, and I can add an exclamation mark. By adding this exclamation mark, we are telling to the TypeScript that, hey, TypeScript, this is never going to be undefined or null. It's always going to have the value inside it. So we are forcing to the TypeScript to have to skip the undefined part and pass the numeric part. So TypeScript is now again happy with all these things. But what if we do the same thing with the fruit2? You can see we are forcing once again. So if I remove the exclamation mark, it's again doing, and we are forcing, although we know that there is no pricing here. But this is kind of hack, you can say, or saying to the TypeScript that, hey, don't care about this, I care about all these things. So not a number is here because we said that this is always going to be a number, and not a number or undefined plus 10 is not a number. So this is the thing. You have to be very careful when using this exclamation mark when forcing for non-null assertion. This is non-null assertion we are forcing. You need to care about that one thing, and second is you need to care about this when you are using optional parameter. So it could be here, or it could be here also. So I say discount is also a number, then you can see it's asking for the discount, but I say that, hey, this is going to be a default value of 0. So if I say discount, that's always valid. But if you don't want to provide any default value, then you can say that, hey, this could be a optional parameter. So these lines are okay when we are using this function, when we are passing, it's okay. But here it says that, hey, object could be undefined, because we said that it's optional thing. So one more time, if you want to skip this, you can force TypeScript that, hey, I will care about these things. So this is okay, but obviously you need to use this, like if we have discount, then only do this part. Okay, so this is how we can understand about the optional parameter and non-null assertions in TypeScript, which is really useful and handy and a little scary. If you like this episode, please give it a thumbs up and comment your views upon the optional parameter and non-null assertion. Do you like or dislike? And if you have not subscribed, hit subscribe button to Bitfim's YouTube channel and like Bitfims on Facebook, Twitter, Instagram. We will meet in the next episode. Till then, goodbye. You know, in JavaScript, we also have the class after the ES 2015. So let's understand and let's see how we can use the typing or TypeScript with the classes. So first, to define a class, you can simply say class and the name of the class. So I'm going to call it coordinate. Okay, and then the body. And if you are not providing anything, that's still a valid class. So this is actually a valid class. So what we do with the class, once you define the class, then you can create the instance of the class. So I say one point is, I'm not on PHP, so I need to say const, and I need to new up this class. So coordinate, and we can just save this. And this is again a valid syntax. So this is about how we can initialize a class. But what we do with the classes, so just like functions, and here we can have the variables, we can have different functions inside the coordinate class simply. So let's define one class called x, and x is just a x-axis, and then we need to also define the y and x are the type, and you can see the TypeScript is guessing the type as any, so that's not an issue. So what we can do, we can simply say console log point dot x and y. You can see as soon as I type point, it says point dot x or y. So if I do this, it's a valid syntax, and if I run it, it's undefined. Yes, we know that there is no value. So once, if we define it like this, and if I hover over it, you can see the type inference is getting it as number. That's super easy things. But as we are on the TypeScript, we always need to define things. So how we can define the type? We just need to say number and number. Once we do this, then obviously it's going to work, but we can also assign the value to our variables inside of the class, or simply call it property. These are the property of the class. So I turn it to 34 from 2. Let's see, and now you can see that it's 34. So what if I give the string? As we know that TypeScript is smart, it says, hey, you are having it here and you cannot add string to number. Now suppose I am not having this. In this case, TypeScript is saying that, okay, there is no issue if you are trying to assign it, I can type inference it, but we can force the TypeScript to check all these things and to force us. So how we can do that? Go to the tsconfig.js, search for strict property initializer. Once you do enable it, check for the class property that are declared but not set in constructor. So what's constructor? Let's close it and see here. So we have this, and what if I just remove the number and I say just the type, not the initialization? So you can see I have set it and initialize it as a type, although we can define the property value outside when we create the instance. There is no harm on doing this, but since we have actually enabled this strict checking, that's why it says, hey, property has no initialization. So what we need to do, we need to create a constructor. So if I do constructor, and first is constructor need some parameter. So when we create the new instance of any class, then we need to pass that parameter value. So here I say I need x and y value. So x is 4, y is 5. Suppose we are doing this, then we need to define that, okay, once you get these two things, then what I can do, I can say this dot x. Now this refer to the class. Okay, this dot x is equal to the x we are getting. Similarly, this dot y is equal to y we are getting. Okay, that's simple thing, and that's a type issue, no worries. But you can see if I run it, we are getting 4 because we have 4 here. If I remove it, now we are getting 4 because of this 4. Maybe we can change it to 44. Yes, so this is how we can initialize the class, and we force to initialize give the value on the constructor. So similar to this, these are the properties and these are parameter. This is very important thing. These are property of the class. These are the parameter when we create the new instance, because when you create the new instance, this constructor run automatically first time. So we can also define it as a number. So I need to say something like this, and this is also a number. Now it's sure that I cannot provide any different value other than the number. So this is how we can have the classes in JavaScript using TypeScript. Now in classes, we have defined these kind of variables. Although I have the 19th folder and everything is inside the 19th one. So I was saying that we have these properties, but we can define the rules for these property, or I can say the visibility rule for these properties. So how we can learn about that? Suppose we are having this x, and we can simply go here and I say, hey, we have this x and let's change the value to something like this. And now if I run it, you can see we are easily able to change the value of x. And this is not good because we have defined here when we initialize the class, and that's the purpose of having this value. So this is not good, and to protect this thing, we can assign the visibility for these properties. So how we can define the visibility thing? So I can say that, hey, this variable x or property x is just a protected one. So as soon as I did this, as soon as I say that, hey, these two are protected, here it says that, hey, you cannot add any value to the protected property. So I can remove it. But the point here is, now next problem is if you cannot even access the value. So if I try, yes, we are getting, but you can see this TypeScript is warning us that, hey, it's not good to read the property directly. So what we can do for this, we can simply create a method and I call it getX, which is going to return this dot x. And by doing this, I can simply say, hey, get me the x, and since it's a method, I can call this one, and now it's working fine with no error from the TypeScript side. So this is once again easy, and we can assign the visibility property here also. So I can say this is going to be a public method or maybe protected method, just like this. You can see once again it's giving the problem. So we can simply say, hey, it's a public method. That's really great. So now what if I have a protected method called ABC, something like that, and if I try to say point dot, you can see we are only getting the suggestion for get x. If this class is in some module, then user will never know about the class ABC, and similar to this, user will never know about the property called x and y. User will only going to know about the get x method, which we have defined it as a public. But you may have seen or may know that one more type is there, which is called private. So if I change it to private, and let's see what's going to happen. Nothing is breaking, nothing is complaining. So what is the change? Now here, the difference between protected and private is that in private, the variables or the properties actually are inside, accessible only inside the class. Now suppose I have another class called my coordinate, okay, and I want to extend this coordinate class. Okay, now let's have the my coordinate. Okay, now inside this I want to create this get method, not on the coordinate. I want that method inside my coordinate. Because we have defined these properties as a private, then only this class can access it, not any other subclass or any other class which extend the coordinate. And that's why we are getting this error. Although once again, if we try to run it, we are getting the value, but that's not a issue because TypeScript is complaining about this. So what we can do to solve this, we can once again convert this to protected. Once you do that, you can see now this my coordinate class is not complaining about this dot x, and we can easily able to run it. Okay, so this means here you can actually set also the value. So public set x. Okay, so this dot x is equal to, let's say, setting x with the value we are getting, with the value, and make sure it's a number. Okay, so what we can do here, we have defined 44. Now let's say point dot, and now we have two method. Let's use the set for 55, and then we run it, we get the 55. This is because we can easily able to access this property inside this my coordinate, since we have the protected. What if we have the private and we try to assign the value, and once again you can see it's not having any happiness phase. The TypeScript is not happy about these things. So one more thing, we understand the public, private and protected. Now let's see the getter and setter. So to understand the getter and setter, let's create a simple getter function, and I call it get. So I can remove the public and I say get with a capital X, and then on the setter I can simply say set with a capital X one more time. But now it says, hey, the X and Y, or X basically is a private thing, you cannot change it. So let's convert it to protected, like here, and now everything is fine. And this time it says, hey, you don't have any set X. So I can comment it, and it says, hey, you don't have small x. What you have, if I run it, you have capital X. And see the magic here. This is saying that X is a property, but we know that we don't have a capital X as the property. So if I try to access it, yes, we are having it. And similar to that, we can assign the value to the capital X, and yes, it is working. But it's not important to have the name as capital. You can name it anything. So anything could be the name, but then the property will become as anything. So now if I say dot, and you can see the property is anything, which is anything. So this is how we create the getter and setter, and we understand the public, private, and protected thing in TypeScript. So if you like this episode, if you like this episode, please give it a thumbs up and subscribe to Bitfume's YouTube channel. Like Bitfumes on Facebook, Twitter, and Instagram. We will meet in the next episode. Till then, goodbye. Now let's look at the class static members and the read-only properties. These are important one, and let's understand by creating a class called fruit. And here I want to create a member, or I can say property, called price. And price is going to be a number, as we know, and this we can define the value in the constructor. So let's create the constructor, and I say constructor, and price once again is a number, and I can say this dot price is equal to price. Let's create the new instance of this. So const, let's say mango, is equal to new fruit, and the price is, let's say, 20. Now that's amazing, and if I try to do the mango dot price, we should get the 20 as we know. But what if we say mango one more time dot price is equal to 1, and then how you can see it's changed to 1. So then you will say, hey, we just learned about the access modifier, so let's make it protected. Once we do that, then we need to do a lot of other work to get the price, like we need to create either a method or a getter. So this is not good, because we just want to read the data. So instead of creating the public properties or private or maybe protected, we can just say I need it as a read only. That means no one can assign the value once its value is assigned either on the constructor or here, just like this. So you can define directly when you add the property, or you can just have inside the constructor for different value for different instance of the class. And this is absolutely amazing, because now we can access the property, but we cannot assign or reassign its value. So this is giving you the power of just reading and not having any changes on that. So can we do something like I want to change the value, so set price, and I can say set dot price. This dot price is 44. Now one more time, you can see it says that, hey, this is just a read-only property, you cannot do that. Now what about the getter? So I can say set, or I can say simply get, like get no, not get set. What I am doing, set the let's say my price, and this dot price one more time, it says, hey, you cannot do this thing. So that's the issue. Now so we understand that, okay, that's an amazing thing for the read only, but we also have a static method. So I'm going to create a count variable, which is going to be a number obviously, and it starts with 0. That's nice. So can we access it? So yes, we can access. And what if the value is 0? But what I want is, whenever I create a new instance of this class, I want to increase the count. So this dot count, and I can say plus plus. Now the count is 1. So let's create another fruit, and this should be apple, and let's define it as a 23 maybe, and then apple.count. Oops. Okay, so what you expect? Should it be 1 or 2? Because we are incrementing 2 times, one in here on the mango and one in apple. So let's run it, and it's 1 and 1. We should get 1 and 2. No, because the name says that mango count is obviously 1, and apple count is again 1 because we are newing the class. But I want to know all the fruit count. So how we can do that? We can just convert this count property to a static property. Static. Now this is very nice. We have done it as a static one, and then instead of this dot count plus plus, I'm going to say fruit. I'm referring the class, not the instance. This is going to give the instance, like mango is an instance of fruit class, apple is the instance of fruit class. But when you say fruit dot count, we are referring to the class itself, not the instance. This means instead of getting it like a mango dot count, I can simply say fruit dot count, and similarly here fruit dot count. Once you do this, if you run it, you can see we are getting 1 and 2. And this is so amazing that we can access the property without any initialization of the class. That means this property called static property is you can say detached from any instance of the class. And one more time, if you don't want to expose the property right here, what you can do, you can actually create the getter or a simple method which is going to return this time fruit dot count. And this is amazing because now what we can do, we can say, hey, this is a protected one. Protected. Now since it's a protected, you cannot access directly from here. What you have to do, you have to say dot and get. What happened? Oh yeah, we need to make this method as static get count, and this means now if I say dot and we get the get count, and it's a method, and yes, 1 and 2 absolute the same result, but we have protected property of the static count. So this is really amazing for the read-only and the static to protect the variables, to protect the properties we have on the classes, which is going to give you so much power on the classes in JavaScript, but with TypeScript. So if you like this episode, please give it a thumbs up, subscribe to Bitfim's YouTube channel, like Bitfims on Facebook, Twitter, Instagram, and we will meet in the next episode. Till then, goodbye. Remember, in the 16th video or 16th episode, we learned about the difference between the type alias and interface. So let's get more into the interfaces of TypeScript. So let's have the 21. So I have just copied once again. To understand the interface once again, let's create a function, and this function is going to like get fruit. And this time I'm going to say fruit is an object of name, which is a string, and price, which is a number. Then here inside this function, I say return, and in a backticks, I say fruit.name, because it's an object, is having price of something $. Let's say fruit.price. That's cool. Let's log this thing, and I say get me the fruit, and it's actually mango with $20. It's really costly. Yes, but you can see now we need to actually provide it as a object, because we are having the type of fruit, which is having an object something like this. This means we need to say now name is mango, price is $20. That's cool. And let's try to run it. And yeah, this is good. But this is very ugly. And here comes the interface. Yes, you can create the type also, but we are learning about the interface. So let's create an interface with a capital F fruit. Copy these things and paste it. And yeah, that's great. And let's define the type as the fruit. So yes, it's an interface, but we are using that interface as a type. And yep, everything is absolutely fine. This means if I try to add it as a string, no, we cannot do that. So this is, we already know, but we are now having more knowledge about the TypeScript. So what we can do is we can say that, hey, this could also have another you can say property, and we can add it inside the interface called color. And color is a string, but it's an optional property. So now if we define it or not, it doesn't matter. So if we define it here, that's okay, but otherwise not. So this is the power of the optional thing. But price is a sensitive thing. Once we set the price, we want, or actually we don't want anyone to change it. So what we can do here, we can actually define let mango is equal to this thing. So like here, and then we pass the mango like here. So everything is fine, $20. But what if I say mango dot price is actually just $9? Let's see. You can see it's now changed. We don't want this to change. So what we can do actually, as you know, if we don't want anything to change, we can call it as a read-only. So this price once set is a read-only thing. So yeah, it's still, we can do that. But what if we define this mango as a fruit? So we defined it as a fruit, and now this means you can see it's saying that, hey, you cannot set a property once defined. So this is now read-only inside the interface. That's really, really cool. Now let's convert these things into a class, because we also know there's a class thing. So class of fruit. But since we also have the interface with the same name, I call it my fruit. And this is a simple class. But let's see what happens when we say implements the interface called fruit. And you can only implement the interface, not the type. If you create the type, you cannot do that. And that's the issue. So we have added the implementation for the fruit interface on my class of my fruit class actually. And now it says you need to define the property called name and price. Okay, so this means I need the name and oops, what happened? And price as string. Oops, price is number. Now it says, hey, you don't have any initializer. So what I can do, I can say constructor of name string price number, and this dot name is equal to name, and this dot price is equal to price. So what happened here, once we implement this fruit, then we are forced to actually use this my class with these properties. We are forced to write these things, and that's how the typing system works. So this is about how we can use the interface in the classes, in the objects, and we can use the read-only for any fields or any type. So a lot of things. Let's get back to the another amazing thing on the TypeScript. But if you like this episode, please give it a thumbs up and subscribe to Bitfume's YouTube channel. Like Bitfume's on Facebook, Twitter, and Instagram. We will meet in the next episode. Till then, goodbye. Let's talk about the generics in TypeScript. And TypeScript generics are real power for the TypeScript. And you will get to know why TypeScript is so famous because of this generics. So first thing first, why we need generic and what problem it solves. So let's first get a scenario. So I'm going to create an array, and I can call it array num because it's a number array. So something like that. I have created some numbers. Now I want to get a random number between these numbers. So what I can do, I can create a function, say get random element, and I'm going to pass this array num. And since this is an array of numbers, so I can type here that, hey, the thing I'm going to pass here is an array of number. Now, for now, I'm just going to return array number with an index. So just saying like, hey, index is 1. So if I call it index, let's see what's going to happen if I log this here with the array num we have. So why don't we call it just arr, not array num, so that we can differentiate between the variable we have created and the argument we are going to pass. Now let's run this and see the result. We are getting 45 because the first element is always the 45, but this index should be randomized. So what I can do, actually, I can first say here, I'm just going to give you the result, math.random. So if I do this, we get number between 0 and 1. So what I can do, I can just multiply with the array length so that I can get number between the length of this. So 1, 2, 3, 4, 5. So we will get number between 1 and 5, actually 0 and 5. So something like that, but it's a decimal number. I want a whole number. So I just need to say math.floor and passing everything. So this will become my index like this. And then I can simply pass this index to get a random number between this array num. So you can see we are getting a random number every time we run this function. This is good. But what if we want to have a similar concept but for array string? So I can say array of string, and if I say A, then we have a B, then we have a C, and so on. So how I can create a function? So it's going to be exactly same, but just going to be different here as the string of array. So now this function is going to accept the string of array with the string elements. So everything is going to same. This is going to exactly same, but since we have type hinted here, we cannot use this function to get the random string. So we need to use a different function, and this is the real problem. So you can see we are getting a random number and a random string also. So D, C, E. Yeah. And this problem can be solved with the generics. So how generics come into the play? Now think about this. What if I create a function and I call it get random element, and let's call this one as random element integer. Okay. And this time I'm going to say it's an array, but the type I don't know. So what I can say, it's an array of any element and it's going to return anything. That's going to solve my problem, obviously. So in this case, I can use this function. So I can just comment these things like here and here. So now I can simply use console log and I can say, hey, give me random element with for array string and array num also. Let's see what's going to happen. And yes, it's working absolutely fine. So is this a generic thing? No, it's not a generic thing. It's just a plain JavaScript because we are not using the power of TypeScript. So what is the issue with this kind of function? Let's see. So suppose I create a result variable and I'm saying that it's a string. Okay, now what I'm going to do, I'm going to just say result is equal to this thing. So what should be the type of this result? Let's see, type of result, and actually like this, and see, type of result is a string. We have defined as a string. That's easy. But what if I define result like here and then see it's a number? Why? Because this get random number returns any, means the TypeScript will infer that, hey, you are returning number. That means the return type should be number. So the container or the variable will now changed with the type of number from string. So this is not a good thing. Once again, we are not using the power of TypeScript. So how we can solve it? We just need to convert from any to capital T. And what is capital T? It's called the generic type. What is generic means? Generic means a thing that can be used in a different scenario and adapt that scenario. How it's going to adapt this thing? Let's see. First, we just need to define it here as T. So here we are saying, let's see what this is saying, that this is a generic type. So type parameter we have given, so generic type T, and now whatever we define here, whatever we pass here will become the T as the type. So see, first we are passing here as string. Now when you pass the string here inside get random element, the T will become the string. Okay, when you pass the number as the parameter here, then this T become number. So that's why if I try to create a result as a string variable, you can see TypeScript is not complaining about this. But as soon as you provide this thing, now TypeScript is complaining that, hey, type number is not assigned to type string. That means this function at this time when we are passing number, this is the number array, when we are passing the number, then T will become a numeric or number as the type and it return the number. So this is why it is complaining. So this is a simplest way of using the generics in TypeScript. You can use any letter. So if I use A, it doesn't matter because we are defining it here that, hey, get random number, we're going to accept a type which currently I don't know, but this is going to be the type what we are passing, and same going to be the type of returning. So this is amazing thing in TypeScript which will going to resolve, or which will going to help us creating a function which are reusable in different use cases, different type cases actually. Okay, so let's continue this generic thing in the next episode. And if you have any question, just write in the comment section, and don't forget to like Bitfumes on Facebook, Twitter, Instagram and LinkedIn. Subscribe to Bitfumes YouTube channel, and we will meet in the next episode. Till then, goodbye. In the last episode, we saw about this generics, but let's extend this generic concept and see how we can use generic with the constraints. And what it is, let's now see. So I'm going to just remove everything and I say it's a generic constraint. Is it right? I don't know, but we are going to learn about the constraints. Okay, so first I'm going to create a type. So I say type, and type is a person, and in this I'm just going to say first name, and this is going to be obviously string. That's cool. Then let's create a function to get person. Okay, and here I will going to have the details. So I just say data. Okay, and I return the data. Nothing fancy, nothing else. That's really easy, but we are using the TypeScript, so we need to define what is the type of data. Since we are not aware of what should be put inside this because we are just returning it, so we can make it as a type of T. And you know what is T? T is a generic type. So we need to define that, hey, this is going to accept the T type, and the data we are passing is going to have a T type. That's not a big deal. Let's get person, and here I need to pass some data. So let's create some details. Okay, and here I'm going to say last name. This is going to be the interesting thing, and my last name. And let's pass last name and actually details. Now see, everything is absolutely fine. TypeScript is having no error, and I'm on 23, so that means I can just go and run this, and I'm getting the last name. But you know, I want to force to have the first name inside the get person. So this means instead of T, can we use the person? So I need to remove this generic thing, and I say, hey, I have a person. But once we have a person, we are losing to send the last name. We will not able to send the last name inside this. So how we can make it general, make it generic? So now what I'm going to do, I will come back with the T as a type, but I will say, hey, this type T is actually going to extend the person type. By doing this, now we are saying that, hey, we want this first name and anything else you pass. So now we are just passing the last name. So now it's complaining that, hey, first name is missing. So we just need to send here and first name, which is Sarthak. Okay, now let's run it, and beautiful, everything is fine. TypeScript is not having any complaint, and this extend thing is generic constraints, because now this T type is yes a generic, but with implementation of this person. That means it need the first name, and anything else you want to give, that will be accepted well. Now here comes another good thing. So suppose we have this thing only, and I'm going to move it like here, and I want to create a function called get element of any object. Okay, so how I can get the object element? So I can just say object and whatever the key I want to get from the object. So I also want the key. This is good, nothing fancy once again, but we are not using the TypeScript here. So let's define that, hey, this is going to be a type of O represent for object, and this is going to be the type of T, because I want to make it generic. So I'm not saying here as a object, because it could be an array also. So I'm going to say, hey, this is going to be the O and the K for key. But now here it says that, hey, K cannot be used as the index for the type O. Why it is? Let's first console log this, and I'm going to say, hey, get me the get element from this detailed function, and give me the first name. Okay, it's going to work because obviously this is just a JavaScript, but here you can see the TypeScript is complaining. So first, what if I am not sending any object here? So I just send detail as a string. So TypeScript should complain that, hey, I need an object, but it's not doing that. Why? Because we have not defined anything. So let's extend this as object, and now this O can be an object extension. So it could be an object, but anything else which extend the object. So I can say this is an object, and now you can see TypeScript doesn't have any complaint, and if I use a string, it's complaining. But still we are not able to get the TypeScript happy by this thing. So what we have to do, we have to say that, hey, this key is actually going to extend, but extending the key of object. So k extends key of k. So now whatever this o we have, we want, it should be o actually. So whatever o object we are passing, the k should be only among the key of this object. This means if I do the first name, TypeScript doesn't have any complaint. But what if I say salary? And you can see instantly TypeScript is complaining that, hey, salary is not a key in the object you are passing here. And as soon as we pass, let's say salary, and let's say something bigger, and now TypeScript is really happy. So this is how we can use the TypeScript generic constraint to extend the power of generic types. So this is really great, and hope you got the idea what is generic and what is generic type. And if you like this episode, please give it a thumbs up, subscribe to Bitfumes YouTube channel, and follow Bitfumes on Facebook, Twitter, Instagram. We will meet in the next episode. Till then, goodbye.